Hello dear learners, today I welcome you for lesson 6 which is related to measurement topic and it is included in Cambridge syllabus. However, it is not included in the book which most of us are following for O levels, that is Physics Matters 4th edition. Here is the contact information. If you face any difficulty regarding today's lesson, you can contact. The topic is measurement of volume using measuring cylinder. Learning outcomes are that you should be able to describe how to use a measuring cylinder to measure the volume of a liquid. You should be able to determine the volume of a solid by displacement. So, the contents which we are going to cover in today's lesson is why we need a measuring cylinder, sizes of measuring cylinders, volume of a solid by displacement, and then practice questions. Why we need a measuring cylinder? Measuring cylinders are used to measure the volumes of liquids. Measuring cylinders are also known as graduated cylinders. Here you can see in a picture the instrument which is known as measuring cylinder. So to measure the volume of a liquid using measuring cylinder, what the user have to do, he or she has to pour some liquid in this measuring cylinder, and then he or she must keep this scale himself towards himself. Here you can see the scale is given to you, marks are given. So maximum mark on this measuring cylinder is 50 ml. So using measuring cylinders, we can measure the volume of liquid. A measuring cylinder measures in milliliter. Volume is measured in milliliters or liters. Sometimes we also measure volume in centimeter cubes. While measuring volume using measuring cylinder, you have to remember some points. That is, avoid parallax error. What is parallax error? That is, when a level of water is viewed from an angle, then there will be a parallax error. The reading which you are going to measure, then it will not be correct. Means to say that the scale is here and you are standing somewhere here and then you are measuring the reading, then there will be a parallax error. So always hold the cylinder at eye level. There must be a line of sight when you are measuring the reading using measuring cylinder, so that parallax error can be avoided. Sizes of measuring cylinders. Measuring cylinders come in a range of sizes, or you can say volume capacities. So here A, B, C, D, E measuring cylinders are given to you. A measuring cylinder has the capacity to measure the volume till 50 ml. And same is the capacity of measuring cylinder B, and in measuring cylinder C the volume capacity, maximum volume capacity is 500 ml, and in measuring cylinder D the maximum volume capacity is 100 ml, and here in E measuring cylinder the maximum capacity for measuring the volume is 3 ml. So we have some liquid in these cylinders. You can see that in measuring cylinder A the volume of the liquid is 37 ml and we are using 50 ml capacity of measuring cylinder. And in measuring cylinder B is also having the capacity to measure maximum volume till 50 ml. So in measuring cylinder B the volume is again having the 37 ml volume. It is 30 mark here and we have 5 divisions here, so it is 35, and after 35 we have 36 and 37 mark, where the level of liquid is aligned or matching with this scale. In measuring cylinder C, the maximum capacity to measure the volume is 500 ml, and the liquid which we have inserted or pour in this measuring cylinder, that is of volume 40 ml. And here we have 3 ml capacity for measuring the volume in this measuring cylinder, but the liquid which we have poured in this, that is of volume 2.3 ml. So while measuring the volume of a liquid, you have to choose appropriate measuring cylinder. When I say appropriate measuring cylinder, it means that you have to select that measuring cylinder according to which your volume can easily be measured. So if I have to measure this 40 ml volume of a liquid, it can be measured with this one, this B measuring cylinder. It will be more appropriate. Or it can be measured with this 100 ml, that is measuring cylinder D. We can measure this 40 ml volume with this cylinder too, but the more appropriate will be this one. In this way we can easily read the mark of this measuring cylinder. Then the value will be more accurate when we are using suitable measuring cylinder for according to the volume of our liquid. Volume of a solid by displacement. As you have seen in previous slides, the process of measuring volume using a measuring cylinder, or you can say graduated cylinder, is very simple and straightforward. So now we are going to measure the volume of a solid. When we are going to measure the volume of a solid using measuring cylinder, it means that solid object will be of irregular shape. If it is of regular shape, then we can measure its volume by measuring the length and then by applying some mathematical formula. But for irregular shaped object, to measure the volume by using mathematical formula is somehow difficult. So we go for this method, that is also known as water displacement method for volume. Suppose I have to measure the volume of this small ball which is shown here to you. I can't use a ruler to find out its length, width and height because of its curved shape. So we have to use water displacement method for measuring its volume. So here is the procedure for measuring the volume of a solid, means to say for irregular shaped objects. What we have to do, first we have to fill the measuring cylinder with water and record the reading of the volume of water. And this is the initial volume. You can call it as V1. Now carefully add an object in a measuring cylinder. Make it show that there is no splashing. After doing this, what you have to do, you have to again read the reading. You have to again record the reading. You have to again measure the reading, and this is known as final volume. That can be called as V2. That is volume of water and an object. Means that volume of water plus the volume of an object. So in the last, after recording this reading, what you have to do, subtract the initial volume from the final volume. The result will be the volume of that object, and I will call that volume of object as VO. So VO is equal to V2 minus V1. V1 is initial volume, V2 is the final volume, that is volume of water and an object. So here we have some example. If you see here, we have some liquid in this measuring cylinder. we fill this measuring cylinder with some liquid, and the volume of the liquid is 200 centimeter cube, because here the unit is given in centimeter cube. So here is the mark where the level is aligned. So it is 200 centimeter cube. So we can measure the volume of irregular object using water displacement. Displacement is the moving of something from its place or position. For example, if an object is placed at point A and we displace that object from point A, or we move that object from point A and that object goes to point B, means that there is some displacement, because that object is moved from point A to point B. So similarly here what is happening, that we have to add this irregular shaped object in this measuring cylinder. After that you will see the level of water is raised. So the level of water you can say is displaced. Previously it was 200 centimeter cube when there was no irregular object is inside. So now if you see, it is displaced. So in between 200 and 300 mark, we have 1, 2, 3, 4, 5 divisions. So one mark is equal to 20, 200 to 20 to 40 to 60 to 80 and 300. So you can say that the level of water, the volume of the liquid now is 260. So here it will be amount of water without object, which we have measured 200 centimeters. Amount of water with object, and that is 260 centimeter cube. This was V1, V2. Now we have to take the difference, which is equal to volume, that is VO, volume of object, is equal to V2 minus V1. This mathematical relation we have to use. So it was 260 minus 200, we will get 60 centimeter cube. So here you have practice questions. Question number 1, find the volume of object. So here one level is given to you. When there is no object, the volume of the liquid is 50 ml. Then what happened? We have inserted or added irregular shaped object in this measuring cylinder. The level or the volume of water is displaced. So note that reading now and then use this relation, you will be having volume of object. Question 2, find the volume after adding two balls. So here the volume when no ball is added in this measuring cylinder, you have to note down this one. And after that what happened, we added two balls in this measuring cylinder. So you have to find the volume after adding two balls, and you have to also tell the volume of one ball here. So VO1 and VO2 you have to find, and you have to drop the answers in the comment section. Thank you so much. If you have not subscribed the channel, subscribe it, and do not forget to hit the like button.